What factors affect the size of a population over time? Let's zoom in to St. Paul Island in Alaska, where reindeer were introduced in 1911. We can look at the size of the reindeer population over time using a graph. The horizontal axis shows time, and the vertical axis shows population size, the number of reindeer. The population increased when the birth rate was greater than the death rate. The population decreased when the death rate was greater than the birth rate. Now, let's look at the pattern of growth in this reindeer population. At first, the reindeer had plenty of food. The population grew slowly, and then grew faster and faster as the population got bigger. This pattern is exponential growth, which occurs when a population has unlimited resources. Of course, resources are never truly unlimited. As the reindeer population exploded, food ran out, and the population crashed. Exponential growth cannot continue forever. St. Paul Island is also home to fur seals. When seal hunting was reduced, the population grew in a way that initially resembled exponential growth. But as growth continued, some individuals could not find suitable breeding space, and the birth rate declined. Eventually, the birth rate equaled the death rate, and the population reached carrying capacity, the maximum population size the habitat can support. This pattern is logistic growth. In Lake Superior, Ile Royale is home to moose, whose population size is shown in red, and wolves, whose population size is shown in blue. As wolves preyed on moose, the moose population crashed and wolf numbers increased. But with fewer prey, the wolf population also crashed. This allowed the moose population to rebound. This pattern of interrelated ups and downs is sometimes seen in predator-prey situations. Some factors that limit population size depend on the density of the population, how many individuals occupy a certain amount of space. Density-dependent factors include limited food, limited breeding space, and predators. Density-independent factors do not depend on population density. For example, an oil spill affects all the birds in the area, regardless of their density. Population ecology helps us understand human population growth and where we might be headed next.